Hi KCET 2025 aspirants. So today we are going to discuss top 30 questions from the chapter Equilibrium and Redox reactions. Okay, both are very low weightage topic, but yes, we have to prepare. So just let's do all the questions and revise all the concepts. Going to the first question here, for the system A plus 2B gives you C. The equilibrium concentrations are given, the K equilibrium for the reaction. So if you see this reaction, the K equilibrium is what? Products by reactant concentration, right? So I can write K equilibrium is equal to concentration of C divided by concentration of B to the power of 2 divided by concentration of A. Now if I substitute all the values, I will get 0.216 divided by B square concentration is 0.12 square, okay, and A concentration is 0.06. Okay, now if I just solve this, you will find the answer to be 250. Very easy calculation, you can do it. So please check the calculation. Okay. Next, it is not possible to attain equilibrium. So always equilibrium is attained in closed system. We cannot attain it in open system. Next, for the reaction 3A plus 2B gives you C, the equilibrium expression will be, so C divided by A cube and B square, right? So option number C here. Next, in a chemical reaction N2 plus 3 H2 gives 2 NH3 at equilibrium point. So when the reaction is at equilibrium, forward reaction will be equal to backward reaction. So I can say the same amount of ammonia is formed, means forward reaction, same amount of ammonia is formed as decomposed. How much ammonia is decomposing? Same amount of ammonia will be forming. So option number D. Next, at 550 Kelvin, the Kc for the following reaction is 10 to the power of 4 moliliter inverse. X and Y equal to Z. At equilibrium, it was observed that X is equal to half, Y equal to half Z. What is the value of Z at equilibrium? Okay. So if I now write for this reaction, K equilibrium will be equal to what? Concentration of Z divided by concentration of X divided by concentration of Y. Okay. Now K equilibrium is equal to 10 to the power of 4, okay. Z value will be how much? Let it be Z only, okay. X value is how much? X value is, I can write half of Z, right. X value is half of Z, so that 2 goes up. And for Y value, it can be written Y is equal to Z, so I can put Z here, okay. Z, Z I can cancel, so I can get Z is equal to 2 into 10 to the power of minus 4, that is option number A here, okay. Next, 2 moles of N2 is mixed with 6 moles of H2 in a closed vessel of 1 liter capacity. If 50% of N2 is converted into NH3 at equilibrium, the value of Kc for the given reaction. So if I have N2 plus 3H2, okay, gives 2NH3. Okay, so we have 2 moles of N2 and 6 moles of H2. Okay, now 50% of N2 has dissociated, that means 1 mole of N2 has dissociated. 1 mole reacts with 3 moles, so 1 mole will react with 3 mole. 1 mole gives you 2 moles, so 1 mole will give you 2 moles. So now what I have here, so how much is left? If I see initially this was at T equal to 0, this was at T equal to equilibrium used. Out of 2 mole, 1 mole is used, so 1 mole is left. Out of 6 moles, 3 mole is used, so 3 moles is left, and I have 2 moles of NH3 left. Right, now if I want to write the Kc value, what is it? Concentration of NH3, okay, square divided by concentration of N2, concentration of H2 to the power of 3. Okay, now NH3 concentration is 2 square, okay, N2 is 1 and H2 is 27. Okay, that gives me 4 by 27, option number A here. Next, for the equation 2A plus B gives 3C plus D, 2 moles of A and B were taken into a flask. The following must always be true when the system attained equilibrium. Okay, now if I see that 2A plus B, okay, gives 3C plus D. Okay, now it have taken 2 moles of A and 2 moles of B. Now it is 2 minus, suppose 2x has reacted and B will be how much? 2 minus x will react. Means see, 2 moles reacts with 1 mole, so 2x mole will react with 1 mole. Now if I see here that I can easily say that concentration of B is greater than concentration of A. right? So or A is less than B, so that is your option number B. Next, 2 moles of HI were heated in a sealed tube at 440 degrees Celsius till the equilibrium was reached. 2 moles of HI was heated. So if I heat HI, what I will get? H2 plus I2, right? 2 moles of HI was heated till the at equilibrium 22% of HI was decomposed. Okay, so at equilibrium what happens? 22% of 2, that means I can say 0.44. How much was used? 0.44 was used. 2 moles give you 1 moles. 0.44 mole will give you 0.22 and 0.22. What is left here after this one? 1.56, right? Now if I want to calculate the K equilibrium, it will be equal to H2I2 concentration, that is product concentration, divided by HI square, right? What is H2 value here? 0.22, I value 0.22, this one is 1.56 into 1.56. Okay, now if I solve this, okay, if I solve this, I will get 0.0199. Okay, so you can just see, so I can write 22 by 156 into 22 by 156. Okay, now you can solve it. I can have, right, 2 11s are 2 7s are 14, 1 78, 11 and 78, right? So it is 121 divided by 78 into 78. Okay, if you solve it, you will get the value. Next, at certain temperature 50% of HI is dissociated into H2 and I2. The equilibrium constant is. So suppose I have 2HI, okay, gives me H2 plus I2. Okay, suppose initially it was 100%, this was 0 0. 50% dissociated, so this one will become 50, right? 50% dissociated. Now how much will be left? 50% will be left, and this one will be 25 and this one will be 25. Now you have to calculate the equilibrium constant. Kc equilibrium constant will be H2I2 divided by HI. So that is 25 into 25 divided by HI 2 times, right? So 50 into 50. So I will get, so I can write the function like this: H2I2 divided by HI square, right? So I will get 1 by 4, which is equal to 0.25. Okay, option number D. Next, given P plus 3Q is equal to 4R, initially the concentration of P is equal to the concentration of Q. If the equilibrium concentrations of P and R are equal, Kc is equal to. Okay, so let us try this question. We have P plus 3Q is equal to 4R. Initially concentration of P is equal to Q, so let it be X, this is be X. Okay, now suppose from X Y amount has reacted, so from here 3Y will react because 1 mole is reacting with 3 moles, so Y will react with 3Y, and I will get 4Y here, right? Because 1 mole is giving 1 mole of P is giving you 4 moles of R, so Y will give you 4Y. Now what is given in the question? At equilibrium concentration of P and R are equal. So if I just substitute X minus Y is equal to 4Y, right? So I can get here X is equal to 5Y. Okay, I will get X is equal to 5Y. Now can I calculate all the concentrations? What is P concentration at equilibrium? X minus Y, right? So that is 5Y minus Y, 4Y. Okay, that's the first thing. Next, if I want to calculate the concentration of Q, that is X minus 3Y, right? And what is the value of X? 5Y minus 3Y, which is equal to 2Y. Next, I have R concentration. R at equilibrium is equal to 4Y, right? So we have got this one. Okay, now I can substitute the values. What is K equilibrium here? That is equal to R concentration to the power of 4 divided by P into Q to the power of 3. Okay, so I have R is 4Y cube, okay, then P is 4Y, okay, then Q is 2Y cube. Okay, now what I can do here is I can just solve it. 4y, 1 4i I can cancel, so I will get 4y square, right? So that means what it will be, just a minute, one second. I have r to the power of 4, p and q to the power of 3. Okay, so I will get here, okay, so now if I substitute this one, okay, so r4, right, 4y cube I will get 4y to the power of 4. Okay, got this one. P is equal to 4y, okay, then q is equal to 2y, that is cube. Okay, now you can see all the y will get cancelled because I have here y to the power of 4, here y and y, so y got cancelled, and then I have 4 to the power of 4, 4 into 2 to the power of 3, 1 4 I 4 cancel, right? So I have 4 to the power of 3, 2 to the power of 3. So I can write 4 by 2 to the power of 3, that is 2 to the 4, 4 to the 8, option number C here. Okay. Next, in the which one of the following Kp is less than Kc? So if you remember, Kp is equal to Kc into RT to the power of delta Ng, right? Now if Kp will be less than Kc, okay, that means what? Kp will be less than Kc. Okay, for that reason we need delta Ng to be negative. If delta Ng will be negative, then what I can write? Kp will be equal to Kc by RT. That means what? When you divide a number from Kc, you are getting a number Kp, right? So Kc is greater than Kp. So we have here negative delta Ng, where I will get here, if I see 2 plus 1, 3 minus 2, 1, delta Ng equal to plus 1. Here if I see 2, and yes, here I will get minus 2, here I will get 1, okay, just a minute, here I am getting delta Ng is equal to plus 1, and here also I will get delta Ng is equal to minus 1 minus 2 minus 1, right? And here 2 minus 4 minus 2. So I can have both B and C as the option, okay, where delta Ng is negative, that will give me the answer, right? So here I have positive and these two are same reactions, so obviously B and C will be the correct answer. You need to find where delta Ng is negative. Next, Kp is equal to Kc, in that delta Ng should be equal to 0, right? If I see the equation, Kp equal to Kc into RT to the power of delta Ng, right? If delta Ng is equal to 0, then Kp equal to Kc, right? So now if you see 3 plus, so delta Ng here equal to minus 2, here it is 2 plus 1, 3 and 2, here it is delta Ng equal to plus 1, and here it is 0 because we have same number of moles, so option number C. Okay. Next, ionic equilibrium will do certain questions. When ammonia is added to pure water, the concentration of which of the following species already present will decrease? Now see, ammonia is a base, right? So when ammonia is added to pure water, in pure water what we have? H plus and OH minus. Now what will happen? The concentration of which of the species already present will decrease. So what if, when you add base, like ammonia is a base, base concentration will increase, acid concentration will decrease, so that is why option number C here. Next, which of the following is the conjugate pair of NH3? So NH3 can donate one H plus, can accept one H plus, both of them, so A and B. Okay. Next, which equilibrium can be described as an acid-base reaction using the Lewis acid-base concept? So if you see this one, here this one is donating electron and this is accepting electron. So according to Lewis acid-base, this is a base, this is an acid, so option number C here. Next, according to Lewis acid-base concept specifies what is molecule in which the central atom has a vacant d orbital acts as an acid. If it is a vacant d orbital, it can accept electrons and it will behave as an Lewis acid. Okay. Next, conjugate base of OH minus. So base of OH minus means this one has to behave as an acid. It will lose H plus and we will get O2 minus if it is loses H plus. Next, in which of the following reactions does NH3 act as an acid? So NH3 will act as an acid means it has to donate H plus, right? So here it is accepting, here also it is accepting, here it is donating. So that is why option number C. Okay. Next, which of the following substance is an Arrhenius base? Arrhenius base means it will have OH minus but not a Bronsted base, means it cannot accept H plus. So that is your NaOH because it has OH but it cannot accept H plus. Which of the species among the following is a Lewis acid but not a Bronsted acid? Lewis acid means what? Don't accept electron pair, that is Lewis acid. And what is Bronsted acid? Donate H plus. Okay, so here the answer will be BF3 because it is having vacant orbital, it can accept electron pair but it will not donate H plus. Next, oxygen has an oxidation state of +2 in which of the following? So if you see OF2, okay, fluorine is more electronegative, here oxygen is +2, fluorine is -2, option number C. In which of the reaction the sulfuric acid acts as an? So if you see sulfuric acid has lost its hydrogen, right? That means it is undergoing oxidation and it will behave as a reducing agent. Okay, just a minute. Yes, it is undergoing removal of H, right? Yes, removal of H is your what I will say, removal of hydrogen is your oxidation, so that is why it will behave as a reducing agent. Next, oxidation number of fluorine in this one, just now I discussed, it is +2. Okay. Next, sorry, one second. Okay, one second. It is -2. Okay. Why? Because fluorine is more electronegative, so it will take the electron, it is -2 and this is +2. Okay. Next, oxidation state of nitrogen in N3H. So let it be X. So I have 3X. Okay. Hydrogen is +1 equal to 0. X will be equal to -1/3, which is option number D. Next, the oxidation state of nitrogen in NO3 minus. Let it be X. This is -6 equal to -1. Then it is equal to +5. Option number D. Next, oxidation number of Fe in K3FeCN6 is. So you have 3, okay, plus X minus 6 is equal to 0. Then X will be equal to +3. Option number B here. Okay. Next, oxidation number of P in the given following. So if I have K equal to +1, H +2, P I want to take X -4 equal to 0. So 3 minus 4 is -1, so X will be equal to +1, that is option number A. Next, in the reaction between PCl3 plus Cl2 gives PCl5, PCl3 is acting as a reductant. So if you see, phosphorus is from +3 to +5, right? It is undergoing oxidation. So definitely it will behave as a reducing agent or reductant, so option number A. Which of the following is not a reducing agent? Okay, so you can see reducing agent means what? It will reduce others, itself it will be undergoing oxidation, right? So if I see sulfur here is in +4 state, it can undergo oxidation to +6 state, so it can act as a reducing agent. H2O2, here the charge is -2, it can further go, right? So that is also oxidation, it is also reducing agent. Carbon, if you see it is +4, it cannot further be oxidized, right? So it will only undergo reduction, so it will behave as an oxidizing agent and not as a reducing agent, so option number C here. Let us see the last question here, oxidation state of oxygen atom in potassium peroxide. So if I have potassium peroxide K2O2, right? Let it be, potassium is +1, so 2 into +1. Oxygen we have to calculate, so 2x, that is equal to 0. Now if I solve this, x will be equal to -1, right? So that is option number C. Okay. So students, these were the top 30 questions from the chapter Equilibrium and Redox Reaction. You can practice similar questions. Just do previous year questions for these type of chapters, PU1 low weightage topics. You can easily able to solve questions in the exam. So do not worry for that. Okay. All the very best, and if you have any doubt, please put down in the comment section. And do not forget to subscribe the channel.